Hey guys, what's up? My name is Gabe, and this is GamesWithGabe, and this is the next episode in the Coding a 2D Game Engine in Java series. In this episode, what we're going to be doing is rendering our game viewport to an actual viewport. So you should be seeing what that looks like right now on the screen. And basically, we're just going to be making it so that whatever you want to render your scene to will be displayed in a frame buffer texture, and that will just be rendered into an image that ImGui will display on one of its panels. Now, this image will be set to a target aspect ratio so that if you are targeting specific aspect ratios, you can see what your game will look like on those aspect ratios inside of the viewport. Now, how does this all work? Real quick before we start to just notice this buttery smooth recording in the 4K. So one of the viewers mentioned a new recording software for screen capture called Streamlabs OBS. I was using OBS previously. I don't know if it's a difference or if it's just because I upgraded it to 4K and 60 Hertz recording frame rate, but it just looks so much better. Anyways, moving on with the episode. What we have here is just sort of a representation of what you saw in that preview before. We have the main window, which is out here, and then I'm just stripping it down to the bare essentials, which is the game viewport, which I will just do GV, which is right here. These are the things we care about. Now, there's a couple things that we have to note because this game viewport right now may be 800 by 600, but this size can definitely change. It is not going to be like this. And clearly this is not to scale because this is way more rectangular than an 800 by 600 ratio would be, but it will help us illustrate a point. So what we want to be able to do is say, okay, so if our panel has an overall width and height of 800 pixels by 600 pixels, and our target aspect ratio, which we'll just call TA right here, is 1920 by 1080, or you could just say that's 16:9, so an HD target aspect ratio. If we are targeting this aspect ratio, where do we place the picture inside of this square? As you notice, we had those black bars, and the reason we had the black bars is because we want our game to maintain an aspect. So what we actually have to do is there's two methods you could go, right? You could either stretch it out, drag it so that it's bigger, and then it would be like over your picture, but then you're losing information. And while you're editing your game, you don't want to stretch it. Maybe in production, that's what you would want to happen. You don't want these black bars, and so that's definitely something we can add support for, so that they do lose a little bit of information, but while you're editing it, you want to be able to see everything. And so instead what we want to do is we want to just have these black bars on the sides so that we can see the whole game scene as it would be from the camera's perspective that's actually in the game world. So we have to figure out, okay, where's the top left corner? Where do I place this game? And what is the width and height inside of here? So what is this width and what is this height, so that we know what to tell ImGui so that ImGui can display the properly sized image and panel inside of our game. Now, all that stuff is not very complicated, okay? So what we do is we'll just label these X, Y, and now it's literally just a geometry problem, right? So ratio is just width over height. So width, if we look at this equation, is just ratio times height. And height is just, if we multiply this, divide this down, just width over ratio, okay? So that's what our X and Y is, right? So this is X, this is Y. That's what we want to solve for. Now, what we can do is, like I said, we can do a little shortcut. So what we'll do instead is we'll just say, okay, let's pretend the width is actually this width. We'll say width equals 800. Okay, what would the height be if we had this width? So then what we would do is we would just plug it in with the R that we want. So we would say, okay, so the R that we want is actually 16:9. We don't want 4:3. So what we do is we just say, okay, plug in 16:9 for R, and then plug in 800 for the width, and that will give us some number. And this number will end up being bigger than 600. It's going to be like some number greater than 600. And so what this is going to tell us is it's going to say, hey, if we try and stretch it, if we try and stretch this image the entire width of this, what we're going to end up with is it's going to be too big. It's going to not fit in there. And so we'll say, oh, okay, well, we can't fit it in the horizontally. So instead, we'll do it vertically. So then we'll say, okay, let's set the height equal to 600 because that's the maximum height we can fit. And then what would the width be? Well, the width would just be, let's plug in our target ratio, which is 16:9, and then 16 to 9 times height, which is 600, and that will give us some number that is less than 800. Then this would tell us, okay, so now if we make it the full height, we will get some width that is less than 800, but that tells us that we have the appropriate width and that we can fit everything into the game viewport. So this is the first step. We just solve for the width and the height, and we just try the width first. If that fits, then we'll just use whatever we get with our calculations. If it doesn't, then we use the height, and then we calculate the width. Now, after we do that, we have to figure out where to place this top left corner, which is very simple once we get the width, because we know what the center is. The center is just 800 divided by 2, which would be 400, and 600 divided by 2, which is 300, right? So that's not too bad. Now we need to calculate what that top left corner is. Well, we know what x is because we just solved for that. So then to get that top left corner, we would just do center minus, and I'm going to do vector notation, x, y over 2. So all that means is whatever x is, let's take in half of that, which would be this length. So if we do 400, which is right here, minus this length, that will get us this x, which that's the right x. And then if we cut the y in half, 300, and we just do, okay, take 300 minus this length, then that will get us right down to here, which is what we want, right? And we could just flip it. So if we had to, we could flip the 300 and the 400. It wouldn't matter. And you'll see what I mean once we actually get into the code and everything. But basically, this is just a very simple solution, just finding where to place something centered, right? You just take the center of the big thing you want, and then you subtract half of the size of the thing you want, and that will give you the position that you want to place it. Okay, so hopefully that made some sense. Let's go ahead and code this real quick and just get it done. All right, so I am just back inside of our project, and if I start it up, we can refresh ourselves. We got the dock space up and running last time, and you can see that right now we would like to have our game viewport be in a little panel down here, just like we saw in the preview. So how do we do that? Well, let's go up into our package. First of all, create a new package, and we're going to call this editor. This is going to be where all of our editor components live, okay? Ideally, it would be separated entirely from our engine, okay? But I'm not doing that because it's a little bit weirder to do in Java than I know. So it's a lot easier to separate this out in C++ with libraries, which you could clearly do in Java too. I'm just not that familiar with doing this type of stuff in Java, and I eventually want to move this series to C++ anyways. So we're going to do it in a way that works, not necessarily the best way. So ideally, this would be in a completely different library than our engine. Anyways, so we'll create this new package to separate it as much as we can. And we're going to go in here and create a new class. We're going to call this GameViewWindow. And this is going to be the window that contains our game view. Now, this is going to be a completely static class, and we're going to have an ImGui function in it, and then some private helper functions, which we'll get to in just a moment. So this is the way I like to do my editor panels. It's just static classes that have an ImGui function because they don't really contain anything. They're just containers, right? They don't really act on any sort of data. There's no reason to have an object. You could, because technically this could be an object, but it's just one thing, right? There's only ever going to be one of these objects. So having it completely static, I think, is fine too. But better practices would be to just have a single object inside of your ImGui layer, which we'll see what I mean in just a second too. Anyways, though, what do we want to happen when we do this? Well, we just talked about it. We want to be able to draw the ImGui window, right? And how do we do that? Well, let's just go ahead and we'll say ImGui.begin, and we'll say game viewport. And we're going to say we do not want this to have a scroll bar because they shouldn't be scrolling in this. And I'm going to do an or symbol and say or ImGui window flags dot no mouse input, no scroll with mouse, so that if they do the scroll wheel, it's not going to try and scroll the window. So we'll just take those two out. And then what we would like to do is say ImVec2 window size. So this is going to be the size of our panel inside of it. So this is going to be the size of the game viewport. Is get largest size for viewport, which is a function that does not exist, but we will create. And then we're going to say ImVec2 window pose. So this is where it's going to be centered inside of our panel. And this is going to be get centered position for viewport. Really clear function names. There's no debate about what those do, and makes it nice and easy to read through this. Then we're going to say ImGui.set cursor pose, and we're going to set the cursor pose to window pose.x, window pose.y. And what this does in ImGui is it basically says, okay, I'm going to set so that the next thing, which in our case is going to be the picture that represents our game scene, that I'm going to place into this window is going to go at this position. So we're basically just saying draw the next thing at this position. Then we're going to get the texture ID for our frame buffer. So we'll say texture ID equals window.get frame buffer, which we don't have, but we will, and then .get texture ID. And I'm going to hit Alt-Enter and import that from Jade. And then lastly, what we're going to do is we're just going to say ImGui.image texture ID window size.x window size.y 0, 1, and 1, 0. What this does is, if we look at the parameters, it just says, okay, so the texture ID, well, we got the texture ID, that's self-explanatory. Size X, size Y. How big is this image that we're doing in this ImGui window going to be? Well, we're making it the window size X and the window size Y. And then it takes into UV0, UVX, UV0Y, UV1X, UV1Y. And that's just saying, okay, based on this texture, where do you want me to sample from that texture? And we're saying 0 to 1 and 1, 0. So the bottom right corner, no, the top left corner to the bottom right corner. And we're doing it backwards like this because otherwise it will show up upside down, and I'll show you what that means too. But basically it's just UV coordinates. There's nothing special about that. Texture coordinates, we've looked at those before. Then we'll say ImGui.end. That's all there is to it. It's really not that bad of a function. Now we need these two functions that we declared but didn't actually use. We'll say get largest size for viewport and private ImVec2 get centered position for viewport. And of course these need to be static as well because we are calling them from a static method. Now I'm going to say you guys should try and implement these. You can see exactly what they're supposed to be. It's very self-explanatory. You know exactly what they're supposed to return. Try and implement it. You may have to look at ImGui's documentation to figure out how to implement it, but you should be able to. And a hint too, it shouldn't take you too long. Anyways, I'll implement those in a minute. For now, let's go into window and create this get frame buffer function. So I'm going to go Control N and then type in window to go to the window class. Go down here, just say public static frame buffer get frame buffer. And I'm going to say return get dot frame buffer. And I'm going to do one more over here, say public static void or float get target aspect ratio, and this will get the target aspect ratio for our game. And I'm just going to say return 16.0f over 9.0f. And hard code it in, we can get this to actually get the monitor's aspect ratio in the future. But for now, this should be fine. If we go back into our game view window, we lose this error now, and now we just have to implement these. So let's implement the largest size for the viewport first, because this one's a little bit easier. So what we want to do is say ImVec2 window size equals new ImVec2. This is going to be the size of the red rectangle in our illustration, the larger rectangle that contains the smaller rectangle, which is the actual game viewport. Then we're going to say that size is ImGui.get content region available, and we're going to pass in window size. And this will just fill in window size with how much space we actually have. And then what we're going to say is window size.x minus equals ImGui.get scrollx, and window size.y minus equals ImGui.get scrollY. And the reason we're doing that is because if we actually take a look inside of here, it says this is equal to getting the content region max minus get cursor pose. So then if we take a look at what get content region max is, let's try and find out. Okay, let's just go into here. If we say ImGui.get content region max, and if I click into here, okay, here we go. So this says this gets the current boundaries, typically window boundaries, including scrolling or current column boundaries and window coordinates. Notice this key phrase, including scrolling. So In order to be super safe here, in case the window accidentally scrolls, we're subtracting out the scroll parameters because we don't care about the scroll. We just want how big we have inside of that red rectangle. All right, so now that we have the size, we're going to say try and get the aspect width and height. So we'll say aspect width equals window size dot x, and then we'll say float aspect height equals aspect width over window dot get target aspect ratio, right? We're just plugging in those equations we talked about. And we'll say if aspect height is greater than window size dot y, so if it's greater than the amount of space we actually have, then we must switch to pillar box mode, which basically just means we have the black bars on the left and right side. So we'll say aspect height equals, and then we'll say window size dot y, and then we'll say aspect width equals aspect height times window dot get target aspect ratio. And this will literally just plugging in those equations. And I totally did not type that right. So let's see if I can rename this real quick. Aspect height. Okay, there we go. Now we have that done, and all we have to do is say return new ImVec2 aspect width and aspect height. This does exactly what we want to do. It gets the largest size that we can fit the viewport into. Okay, then for the centered viewport, what we're going to do is we're actually going to take in an ImVec2 aspect size. So this was a little misleading. I should have put this in there too before telling you guys to try it, but we do need to add in the window size, and that will just help us that we can center it appropriately within the full window. So then we'll say in here, ImVec2 window size. Once again, this is the red area, so the overall window size. And we'll do the same thing, get content region available, window size. And if we pulled all this out into this function, we could reduce that duplication. But I like having these in their own functions better because it's a little bit more readable. And we'll do this again one more time. Technically, we could make a function to do that and save a little bit of time, but it's fine. Then we're going to say float viewport x. So where is the x position centered? And we're going to say that is window size.x over 2.0f. So over the center x minus aspect size dot x over 2.0f. And we'll do the same thing for viewport y. Window size dot y over 2 minus aspect size dot y over 2. And then we'll just return a new ImVec2 viewport x, viewport y. And we're going to have to do one more thing, which I will show you in just a minute, but we'll leave it at this. And so this is just doing exactly what we talked about. Once again, it's just taking the center x, subtracting half the size of the smaller rectangle that we can fit inside, and same thing with the y's, which gets us the appropriate x and y. And that is it. Our function is done. Real quickly, though, we're going to notice that we have a problem when we try and do this. Well, first of all, we're not even calling it, so it's not going to do anything. But if we go into our window, or actually let's go into our ImGui layer, and I'm going to say right after we show the demo window, what I'm going to do is say game view window dot ImGui, just so that we call ImGui right inside ImGui with everything else. Okay, so now if we do that, you notice you'll get this tiny window up here. If we pull this out and then we say put this down here, first of all, you'll notice it looks like it's growing correctly and everything, but it's all black. And you're like, okay, why is it all black? And well, that's because we didn't enable our frame buffer. So let's go into our window class, uncomment this line. Now we actually have our frame buffer being drawn to. So if we run this again, okay, it's still black. Why is it still black? That doesn't look right. And the reason it's still black is because if we go into frame buffer, so I'm going to Control N frame buffer, you'll notice that we create a new texture for it right here, right? Okay, if we go into texture, we never define what to do with the texture if it's bigger or smaller than what it should be. So this was a problem that I ran into a while ago, and it took me forever to figure out why I wasn't seeing anything on my frame buffer. And basically, if you don't define what should happen when you have your min filter or your mag filter, it doesn't do anything. And if you remember, the min filter and the mag filter are literally just what to do if your image is stretching or if it is shrinking. And so if we say linear, then this will make it so that it blurs it as it stretches and shrinks. And then if we said closest, that would pixelate our values as we stretched and shrunk. And there you go. It looks sort of right. We get a black screen with our lines, and the reason we're getting the black screen, if we go back into our window, you'll notice that we don't bind our frame buffer. You'll notice we bind our frame buffer after we clear color, when we really should bind our frame buffer before we do clear color. That way we make sure to get our clear color in there. And then it is now a white screen, and if we move our stuff around, it all works properly. What you'll notice though is that this does not look right, right? We have this little space up here, first of all, and second of all, we have a space down here. The reason for this space is because we're not taking into account this title bar. And so the way we can take into account that title bar is if we just go into the game view window, right here when we're getting the centered position, we should just add in ImGui.getCursorPoseX and plus ImGui.getCursorPoseY. And that will just make sure that we take into account that title bar height. But that doesn't explain why we get this thing. And the reason we're getting this white space is because we are never calling GL Viewport. And what basically GL Viewport does is it defines the maximum size you're going to draw to. And so the space we're drawing to is that frame buffer. And if we look at the frame buffer, we can see that when we create the frame buffer in the window, we see create a new frame buffer of size 3840 by 2160. And basically what that means is we would also need to make sure that we're drawing to a size of 3840 by 2160. So if we call GL Viewport and we pass in 0, 0, and then the width and the height, then we should see that problem disappear as well. And there we go. Now we get it drawn perfectly as it should, and there's no weird errors. Last thing you're going to notice, first of all, we can't click onto this. That's because this window is consuming the click events. We'll have to fix that. Second of all, why is the block way off from my mouse? And notice how it gets closer as I get closer down there. That does not look right. The reason for that is because now that our game viewport is sort of sitting in here, I don't know how it just changed up everything too. But now that our game viewport is sitting inside of here, we actually have the wrong mouse coordinates, right? Because right now we're calculating the mouse coordinates in this entire window, which is this entire thing, the entire size. But really what we need to do is calculate it as if the window started here and ended here, if the mouse is inside here. It's kind of confusing, but we'll talk about this in more depth in the next tutorial. That does cover it for this tutorial though. We have a game viewport up and running, and this is starting to look more and more like an engine. I hope you guys enjoyed this. If you did, please hit like and subscribe, and I'll see you guys in the next video. Thanks.